So I just want to show you a little bit about how our technology works, how we approach solar air heat. So this is just a very brief, simple schematic of the way in which a typical residential solar air heating installation works. So when you're looking at this installation right here, a schematic of this simple residential installation is represented by this. Essentially, we've got two collectors in parallel. Now, the reason I emphasize that is because we kind of took a chapter from the flat plate solar water heating industry, and we applied it to the solar air heating industry. So when we started our business in 2000, quite frankly, we had no intention whatsoever of becoming a manufacturer. When we started, we wanted simply to deliver solar thermal to low-income communities and low-income families. And so what we did is we purchased product from all across the world, from Canada, from New Mexico, Michigan, New England, and we delivered solar thermal systems to low-income families. And we had the opportunity to work with a really broad spectrum of solar air heating collectors. And we learned what worked, and we learned what didn't. And we learned a lot more about what didn't. And one of the things that was challenging was doing relatively large arrays. It was very difficult with existing product to do large arrays, either large residential or commercial arrays. So we simply said, there's a lot to learn from the flat plate solar water heating industry. Let's see how we can apply that to the solar air heating industry. So basically, we created an internal manifold. So for those of you that are familiar with flat plate solar water heating collectors, you're able to couple them like Legos with an integrated manifold. We can do the same thing now with solar air heat, which is why some of those commercial installations that I showed you earlier are possible. That's why those system installations are possible. There are very few solar air heating technologies out there outside of transpired air that are appropriate for commercial installations. So this is one of the things that's kind of unique about how we approach it. So here in this installation in Fond du Lac, up in northeast Minnesota, you can actually see those manifolds. So we've drawn just a little schematic over the collectors. So the red lines, everything up and everything above and below those red lines indicate how those collectors are connected. So we can do that with 2 collectors, or we can do that with 20 collectors. So it's kind of an interesting approach to solar air heat, and you can see the supply and return penetrations indicated by the little yellow circles. One of the things I also want to point out with this installation is that this installation was monitored by the state of Minnesota. Now, with our solar assistance program, which I'll tell you a little bit more about in a second, we always wait for the weatherization community to come in and improve the overall efficiency of a home, whether it's additional air sealing, additional insulation, whatever the case might be. We always do a solar installation after the weatherization event. So between weatherization and our solar assistance installation, this household, literally reduced its energy burden by 50%. And that was about a 50-50 between the energy efficiency upgrades and the solar assistance. So those two, again, that speaks to the power and the importance of energy efficiency. Those two in tandem with one another created a great deal of savings for this household, and of course a great deal of reduction in greenhouse gas emissions. So like I said, not only can it be done at the residential level, but also at the commercial level. So I just want to point out that you've got your grill there, basically, your air handling unit, your backdraft damper, 7 collectors, 2 supplies, and it looks like this on a building. This is a transportation garage in St. Louis County. Only for 4 months out of the year does this building require any additional heat beyond the solar air heating system. And even during those 4 months, it's about a 50-50 between the solar air heating system and the gas backup. So it's a very powerful technology. So the solar air heating system on this building is doing a solar fraction of about 35 to 40%. So it's a really flexible technology. Not only can you do parallel connections, but you can also do series connections. So I want to share with you now just a brief case study of the building where we actually manufacture our collectors. It's a really unique building. It's 15,000 square feet. Our highest heating bill for the entire year for this relatively large building was about $1,000. Now again, that speaks to the power of efficiency because this building was built to the Passive House standard. It didn't quite meet the certification, but it's very close. It's 14-inch SIP walls, extremely well insulated, and it also has a large storage system. So earlier I said that typically solar air heating systems don't have storage other than a well air-sealed tight envelope. With this building, there's actually an exception. We do have a large storage system with this building. Typically we don't encourage that But with this building, we were experimenting since it's the building where we make the collectors. And again, you can see all 76 collectors across the building. And this is what the storage system looks like. So beneath the building, we have a massive sand bed that's insulated. And the air is literally pumped through the sand, through a corrugated drain tile of sorts. And that sand is actually charged year-round. So even in July, we're sending heat down to the very bottom of that sand storage. So then in August, we send up to the next layer. In September, a little bit higher. And then during the heating season, the vast majority of the energy is being delivered just below the slab. And as a result, this building has a solar fraction of between 60 to 80% depending on the year. This year, because it was pretty mild, it was closer to 80. So it's a really interesting building. Here you can see the installation underway. And by the way, solar air heating collectors are typically a vertically mounted technology. Why do you think that is? Not always. It can certainly be roof mounted. It can be ground mounted. It's very flexible, but we always encourage people to vertically mount when possible. Why? Todd.
Well, structural issues are almost eliminated, and it's about the best, if you're a winter-only collector or a swing season in winter, it's the best angle.
Absolutely. Those are two huge ones. Architecturally, it's very easy to attach to the structure of the building. If you can get down to the sheathing like this, always want to put your collectors on the sheathing, not on siding. And as far as solar resource is concerned, you're always trying to obtain perpendicularity with any solar technology. So for heating seasons, we approach or approximate perpendicularity because the sun, of course, is lower in the sky. So you get greater performance. The other thing is with my systems, I have an off-grid solar electric home. After a heavy, wet snowfall, I'm without power often for a significant period of time because I've got an angled mount on the roof. It's steeply pitched even, and snow can slough off there. But for a period of time, it's definitely not producing much of anything. Sometimes I throw snowballs at my array because I don't want to get up on my metal roof after a heavy snowfall. With vertically mounted solar air heating collectors, non-issue. We never have snow buildup on a solar air heating collector. The other thing is that our summer temperatures in solar air collectors are at their absolute lowest at summer solstice. We see the lowest temperatures in the collectors at summer solstice and the highest temperatures at winter solstice. So you get the best performance by vertically mounting. And all solar energy systems, as you all know better than most, direct beam radiation, diffuse radiation, and reflected radiation. So by putting them vertical, you can actually see an increase in performance of about 10 to 15% when you've got snow cover. So that's another advantage. And architecturally, it typically looks better than to have some sort of a racking system off the side of the building or on the rooftop. And cost. It's almost always a lower cost approach as well. So here you can see just a very brief schematic of how the solar air heating collectors actually get down to the storage. I won't go into a lot of detail about this, but I will share the fact that you can monitor this entire system right now. For those of you that have access to wireless, you can see what any one of these sensors are right now. So we wanted all this data to be publicly available. So you can go to this website and you can look at every single sensor. There are about 1,000 sensors in this building, about half of which are in the collectors, the other half are in the sand storage. You can see the collector temperature instantly at any given point in time. You can look at historical data. So it's a really interesting building. And by the way, if anyone is interested in coming and taking a tour, you're more than welcome to do so. Pine River is about a 3-hour drive, though. And we think that solar air heat can be incorporated into commercial buildings in a way that looks sharp also. And it also can replace siding. You noticed earlier from the installation photos that there's no siding above and beyond the solar collectors.